Welcome to another video, the same every time, IGCSE Maths, GCSE Maths. We're still looking at right-angled trigonometry. Trigonometry in right-angled triangles. But look at this question, we've stepped things up a level here. And these are what we might call two-part questions, where to get the answer that they are asking for, we're going to have to work out something first that they were not asking for. So we're stepping things up to the next level of question, really. But it is still the same every time. We just have to break it down into small chunks. Let's see what was going on here. So the diagram shows right-angled triangles, PQS and PRS, so we have two right-angled triangles, and they tell us everything in the words that's in the picture, don't they? So P to Q, Q to S, and S to R, and they want us to calculate P to R. So in the end, what they want us to do is calculate this length here, the length of that side from P to R, and we are going to have to use a right-angled triangle. So this right-angled triangle just here. There it is. Well, we don't have enough information, do we? Because in order to work out the length of that side from P to R, this side just here, I'm going to need that side just there and that side just there. Then I can use Pythagoras theorem, can't I? If I have this side here, the side from P to S, I will be able to use Pythagoras theorem in this right-angled triangle in order to find the side from P to R. So they're not asking me in the question to find the side from P to S, but I am going to have to do that before I can do anything else in this question. So let's look at this triangle first, this triangle. And, well, I can see this is going to be a Pythagoras theorem question, this one, isn't it? So trigonometry and Pythagoras, they often turn up in the same questions. This is going to be a Pythagoras theorem. To find P to S, well, I've got two sides of my right-angled triangle, 23.8 and 11.2. And are they asking me to find the longest side or one of the shorter sides? Well, the longest side is always the side opposite the right angle. So in this case, 23.8. And P to S is one of the shorter sides. So it's going to be square, square, subtract, square root. So side P to S is going to be square, square, subtract, square root. Have a look at the videos about Pythagoras theorem if you're not sure about this. So 23.8 squared minus 11.2 squared inside a square root, and that gives me 21. So I know that P to S now is 21, so P to S is 21 centimeters. And now I'm working with this right-angled triangle just here because the question actually wants me to find P to R. Now, if I look at that right-angled triangle, the one on the right-hand side, the PRS triangle, P to R is the longest side. It's the side opposite the right angle. So using Pythagoras theorem to find the longest side, it's going to be square, square, add square root to find the longest side. And calculator job for this one, 21 squared plus 20 squared inside a square root sign. And again, that gives me a nice whole number. So they've been quite nice to us with this question, haven't they? So 29. So P to R, 29 centimeters. So not strictly speaking a trigonometry question there. No sine, cosine, or tan. We didn't need to use any angles or find any angles, but it's a nice introduction to this style of question where we have to find, first of all, something that they're not asking for, so that we can find the thing that they are asking for. Here's another exam question, and you can see in this question, or you will see in this question, that they are mixing together Pythagoras theorem and trigonometry. There's an angle in there, isn't there, in the BDC triangle, and the ABD triangle has two sides given and there's a side missing. So they're mixing together Pythagoras theorem and trigonometry in this particular question. It's the same kind of idea as the last question we looked at. We're going to have to work out first something that they're not asking us for in order to find out the thing that they are asking us for. Let's see what's going on here though. Show that. It's a show that question. So show that the height of the flagpole. I haven't actually read the words here. Maybe we should read the words, but I don't think they are telling us anything in the words that they are not actually showing us in the picture. So, no, they're not, are they? So everything in the words is in the picture. Show that the height of the flagpole, B to D, is 13.3 meters, correct to 1 decimal place. So they want this side here, B to D. It's a show that question, so we are going to have all of our working out. So just like the last question that we did, we are going to use this right angle triangle. So forget about everything else in the question. We're using this right angle triangle, and I've got two sides of that right angle triangle, and they're asking me to find the third side. Now, are they asking me to find a longest side or one of the shorter sides? Well, the longest side is always the side opposite the right angle. In this case, that must be the 21.2. So B to D is one of the shorter sides. So it's going to be square, subtract, square root. Now, this is a show that question, and they're saying show that the height of the flagpole is 13.3 meters, correct to 1 decimal place. So they do expect us to write down all the working out. And if you watched an earlier video in this particular set, I did say that if they are asking us show that question and it's got rounding in it, so show that the height of the flagpole is 13.3, correct to 1 decimal place, they do expect us to write down the full calculator answer. So square root 21.2 squared minus 16.5 squared. And I'm writing now my full calculator answer here. So 13.311273442. Well, I can see just from looking at my calculator that that's going to round to 13.3 to 1 decimal place, but that's not the point. The point is that this question is worth 3 marks, and the mark scheme of this question will be very clear that they will expect you to show the unrounded answer and then show that that answer rounds to 13.3 to 1 decimal place. So they do expect to see the full calculator answer for this one, as well as the rounded answer. Remembering that it's a show that, we need to see every stage of our working out. Part B of this question says calculate the length of the rope C to D. So we're finding the side C to D, and this is worth 3 marks as well. So we are in the other right angle triangle now. So this right angle triangle just here, and they want us to find the length of the rope from C to D. Well, the angle at B here, that must be a right angle as well, mustn't it? Because it's on a straight line with the other right angle. So that means that the length from D to C, if I label it with my O, A, or H labels, that's the side opposite the right angle, so that must be H. And the other side, the side opposite the 48 degrees, I know is 13.3, and that would be the opposite side. The B to C, that would be the adjacent, but we don't need it. Now, you might have heard me in other videos saying never use a rounded answer in a calculation. However, in this case, we may use B to D is 13.3. Why? Because they're actually telling us. They say, show that the height of the flagpole is 13.3, correct to 1 decimal place. If there's a show that question and we have to use the information in the show that question or the value from the show that question again, it is perfectly fine to use the value that they tell us in the question. So yes, we could use our full calculator answer, but they will be quite happy with us using the 13.3 that they tell us. Because it's a show that question, the reason they do the show that, so suppose in some questions, is so that you can still have a go at the second part, even if you get the first part wrong. So they do want us to use the value 13.3. But having said that, if you use a more accurate answer, the full calculator answer, they'll be fine with that as well, won't they? Anyway, in this triangle, O and H, we have to decide, are we using sine, cosine, or tan? And it's O and H. We know the value of O and we want to find the value of H, so it's going to be sine. So that's O divide by H. So O was 13.3. Divide by H, which we don't know, is sine, in this case, sine of the angle, and the angle is 48 degrees. So we just have to do a bit of a rearrangement here. So 13.3 dividing by H on the left-hand side, multiply by H on the right-hand side, H times sine 48. So H times sine 48 degrees is equal to 13.3. Remembering that sine 48 degrees is just some number, so 13.3 now divide by and multiplying by sine 48 degrees on the left-hand side, so I can divide on the right-hand side. So calculated job then, 13.3 divide by sine 48 gives me this, 17.8969153. And I'm going to write that to my final answer, a sensible degree of accuracy. And I'm going to go with, because it's a length, 3 significant figures, so 17.9. That would be meters, wouldn't it? 3 significant figures. But always check the question just to make sure that they have not given you an instruction to write it to a particular degree of accuracy. In this case, they did not. So I'm going to go with 3 significant figures. If you look at a Cambridge exam, they do tell you to round non-exact answers to 3 significant figures. In the next video, we'll have a look at more questions that are a little bit like those, where we have to find sides that are not part of our final answer before we can find our final answer, where we have to split the question into 2 different parts. I hope that video was useful to you, and I hope you can see that even though these questions maybe, when you first see them, they look like they're going to be a little bit complicated. Remembering we can't go straight to the answer, we have to split it into 2 parts. And when you do split it into 2 parts, it's just 2 right-angled triangles. We're just doing right-angled trigonometry or Pythagoras theorem 2 times. If that was useful, then please do like and subscribe. Thank you very much for watching. I will be back with the next video.